Welcome to Maths with EJD. In this video, I'll be showing you the Python code for the simplex method solution to an investment portfolio problem, which was solved in the previous video. And doing that manually took more than 1 hour, you know. But when the problem gets really high dimensional like that, computation may become necessary. Again, you can see the problem statement. I ran through that previously, exactly the same problem about investment. An investor has three different investment opportunities, I1, I2, and I3. Each investment yields a certain return and requires a certain amount of funds, time commitment, and risk tolerance. The investor wants to maximize their total return while staying within the constraints of their available resources. So you have all the story there. This is the mathematical representation like we had previously. So maximize z equals 40x plus 50y plus 35z, subject to 2x plus 4y plus 3z is less than or equal to 100, 3x plus y plus 2z is less than or equal to 60, and x plus 2y plus z is less than or equal to 40. And you have the non-negative constraints of x, y, z being greater than or equal to 0. So the Python code is pretty easy. Now, since we have three variables now, you can no longer have a two-dimensional graph. It has to be a solid graph, a three-dimensional graph. So the way to just solve it. Now, NumPy, of course, for numerical calculations, like let me see where NumPy is used in this code, for instance. NumPy. I've not seen it anywhere. Okay, yeah, you need numpy for all these masking invalid values where x3 becomes negative. So we want to remove those ideas. So that mask thing is coming from numpy, for instance. Then all the lim space, like, having your x-axis and spacing it out, that is from numpy also. Then you need matplotlib for normal plotting. You need scipy.optimize for the actual linear programming, the optimization we are here to do. And then okay, I need to show the line numbers, right? So line 7 is where we are declaring the 40 minus 40 minus 50 minus 35, that's the z part, right? And then we have the coefficients of the constraint 243, 312, 121 already. Then the right hand side has the b thing, which is 100, 60, 40. Then in lines 20 and 21, we describe the bounds, talking about the fact that they are non-negative. And the actual work is actually happening in line 24, where you have result equals linear program. You put C, AUB, A underscore UB is A, and all the bounds, and then you're using the simplex method. Then lines 27 to 33 is where we are extracting the results. So optimal investment in one will be result from X0, X1, X2 for the other investment 2 and 3 also. And then because we negated the maximum value initially, we have to put the negative back so we can get a positive result. And then every other thing is to create the plot. Because it is a 3D plot and it requires a bit more stress. So everything from line 36 down to line 75 is just to show the graph. Okay, let me do this. Okay, so now if you just run this in one blow, you get the results that we were trying to get for that took us over an hour. So you see the optimal investment in first investment is 4.0. Optimal investment in I2 is 8, in I3 is 20, exactly what we got the other time. And the maximum total return will be $1,260, like we found already. And you have a graph to match it. So you see, this dot is where all of that comes together. That's 4, 8, 20. Okay. 4 on the one axis, that's 4. So you see this line is somewhere around 4, somewhere here. Then for the second one, it's like around 8, and this is between 0 and 10. So 8, so you can see the projection. 8 is somewhere around here. And then for the third axis, so that's around 20, and that's what exactly you have. So what we did manually for 1 hour is taking us, like, even if I have to write the code from the scratch, highest maybe it will take like 20 minutes to write everything line by line. So we have the result there to verify and to make things faster. So once you, as the more variables you have, the more they need to compute, like what we have here right now. Okay, so if you have not subscribed to this channel, be sure to do that. And of course, hit the notification bell so you can always get alerted each time a new video is released. And comment, let me know if you want me to teach a topic or solve a problem. Then like and share so that more people can have access to all of this great learning. Till I come your way again, keep optimizing. Bye.